Okay, so let's proceed. So as you can see, this is the given problems. A company earned before tax this. So let's move to the next slide and we see our model. Hello, come on, are you with me?
Hello, I'm not sure Kamal is here. Good evening, Afi. This is Halima.
I'm here, Halima.
Kamal is not here with us. Let's
Oh, okay. Good
come
evening.
on, go to the next slide. Let's proceed. We
I'm with you.
wasted almost. Go to the next slide.
I'm with you. I'm with you.
I said go to the next slide.
Okay. Okay.
Okay, so these are the detailed solutions by obtaining
Okay, that is exactly what
the
I'm.
simultaneous linear equation. So if we obtain this, we have first equation, equation I. So without a model to structure our analysis, the problem is rather difficult because each of the three payment must take into consideration. So we let represent the linear equations where describe the variables as S for the state, C for the charitable donation contribution, while F is for the federal level. So we have the state tax, federal tax, and charitable contribution. So we form the system. First of all, what is the total profit of the company? So we look at the total company earns, which is $100,000. Then we subtract the state followed by what? The federal. So that will give us the solution for the what? The company donation or contribution. As you can see here, where C equals to 0.110, 0.10, open bracket, the total income. So we rewrite this equation like this. We also look for the state contribution, which is S equals to 0.05 times this. We also rewrite the federal contribution, which is 0.4. So if you look at this, we find out that what is the contribution for the state? What is the contribution for the federal level? What is the contribution for the charitable contribution? So at federal level we have the company earn of $100,000. So if we take this, if we divide this through, we take total income, which is equals to $100,000. Then we divide each result by this what total donation. So we look for the state level, which is earning a profit of 50,000. We look for the federal level, we have the 40,000 donation. So each of these ones we divide this, we have 0.10%, 0.505, and also 0.4. So we multiply each term by the subsequent. Like this one here, for the first equation we subtract the set plus what? The federal level. The second equation we subtract the charitable contribution, while the third we subtract the contribution plus the state. So we summarize the result like this. So by solving this system of what? Threefold. So solving this either by elimination method or substitution method, it will yield the result. Where we have that by solving and analyzing this solution, we have C equals to 5,956. The state level is 4,702, and the federal level is at 5,787. What we only need to do is what? After developing this model, we try to solve the system by solving the exact value for C, exact value for S, and exact value for F. So at the end, we go back to the given problems and do the proper interpretation. So maybe we'll show the techniques of the proof on board. Do we need to solve the system on board? Hello, class.
Hello, are you? Hello, sorry. Good evening. All. Are you talking of what we are seeing
Yeah,
right now on the screen? Whether you
this
want
is what I'm
to
explaining.
do it on the
This
board?
is system of for better understanding. Yeah.
Okay, I don't know if it has been handled or you've presented it before now, because everything here look abstract. I don't even understand what all these things. Maybe I
It looks
from the previous class also. I don't know.
it is look abstract.
Look abstract.
So you want
Maybe.
You want it to be mathematical, right?
Yes.
Okay, let's see. Let's project the board so that we can be able to do the mathematical manipulations and see. Let me clean the board. Are you seeing the board now?
It is blurry.
Okay, let me see if what of now?
You need to move the camera backwards a little.
What of now?
Right on the board, let's see if
Exactly.
it is.
Right on it, let us see.
Let's see. Let me use red. Are you seeing it like this?
Yes, but right on it, let's see.
Yeah, it
Right
has
on
to
it,
be
let's
very
see.
close to the board. So that let's say we have to the three contribution, which is the charitable contribution, the federal level, and the state. Are you seeing it like this?
Yeah, we are seeing it, but 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 to me, you need to move your camera so that you can capture the board fully.
Okay, so let me 1 minute.
Yeah, because it's too you.
What up now? Are we seeing it?
Yeah, it's okay now. It's better.
So let's manage it like this. So if you go back to the question, right? If you can take a look at the question, we say that a company earned before tax a profit of what? $100,000. It has agreed to contribute 10% of its tax profit to the Red Cross Relief Fund. It must pay a state tax of 5% of its profit at the Red Cross donation and federal tax of 40% of its profit. So in this case, we model the equations as follows. First of all, the company agreed to pay the 10% of its profit to the tax at the Red Cross. So we have what? At C, we have C of what? 10%. Are we seeing it here?
Yeah, we can see it.
So you have 10% of what? The gross profit. At federal level, we also have At federal level, we have 5%. At federal level, we have 40%. So right at federal level, we have that of what? 40%. And also at the state level, we have what? Donation of 5%. So these are what? our charitable contributions. Are we seeing it?
Yeah, we can see it. Just go on. We can
So
see
in
it.
this case, what is 10%? 10% is something like 10 over what? 100, and this equals 0. What? 1. So I can write it in 3 digits
0.0.
to be 0.10, right? In this mark point. Agree?
Yes, yes.
So similarly, the 40% is going to be what? 40 over what? 100, and this equals to what? 0.40.
0.4.
So we write it in 3 digits, which will be 0.40. Similarly, 5% will be 5 over what? 100, and this equals
0.005.
So these are what the contribution that the company is donating to the tax, right? Are you with me?
We are with you. We are with you.
So in this case, what is the value of C? What is the value of S? And what is the value of what? F? So therefore, the contribution, therefore the contribution of each, the contribution is given by what? The total profit that the company is earning. What the total company earns is $100,000, right? Are we seeing it?
Yes, we can see it.
Yes.
So this is the total a company what earn, and it's also at a particular period of time, minus what is the company is donating now. The total profit minus what? Donation. That is the total company what earns. The company earning is the total profit minus what? Total contribution. I hope it's clear. Hello, class.
You
Hello.
can continue.
Okay. So now, what will be the first contribution? So we should either consider what, since we have 3 variables here, 3 contribution, we have C, F, and S. So either we first of all we denote with S plus what? F. We form a first contribution. And the second contribution we denote what? S with what? C. While the third contribution we denote what? F and what? C. So these are the 3 what donation that we have.
Hello, Malan.
Yes.
Malan.
Yes.
Right now, we can't see what is below the contribution is
Okay,
giving.
so let me take it off.
After the contribution is given, it has gone down. That was the reason why I told you that the only way we can see the board clearly is for you to move the camera backward. You understand? If not, we can't see whatever you are writing below here.
Okay,
You
let
get?
me.
So except you move it back.
Are we seeing the board now?
It's still not better.
It's not better.
It is
Yes.
tilted. It's tilted. It's looking upward. It's tilted, looking upward.
What up now? Look at it now. Is it okay?
But you have to extend your hand up when writing.
Okay.
So you can clean it and start from that contribution, the one you just clean, but extend your hand up.
Okay. Look at it now. We say since the company, what the total earn for the
I
company?
think Malan, what you need to do is to divide the
Both.
board into two. Finish from one side and the other side, so that it will save space and your writing, so that you minimize. Just share it into two. Yawa.
You are saying, yeah, well, welcome to Hausa area. So we have this. So we say that what the total earns of the company. So the total earn is what? 100,000 right? Agreed? Are you seeing it? Are we seeing the writing now?
Yes, we can see it.
Okay. So this is total outcomes. And what is our contribution out of this profit? We are contributing toward the federal tax, F, the state tax, and charitable contribution, that's FSC. So first of all, we are to find what the amount that the company is donating to the federal level, the state level, and what the contribution. Are we seeing it? So therefore, since the total n is this, so we form what? Three different system of equation. Equation number one, we have the total, which is $100,000 minus. First equation can take any two of these. So first of all, we take the state level plus the federal tax. We call this what? Expression one. The second one will now be 100,000 what? Profit minus what? The S plus what? The charitable contribution. We call it equation what? 2. The third one will be the total company N minus what? The state. Since here we have the state and federal, the second equation is the state and contribution, while the last one will be what? The federal and what? The contribution. This will be expression what? 3. So now we have what? 3 different relations. As we can see, we have three different what? Relationship. If we take a look at this, we found out that at the federal level, the company is donating what? How many percent of this profit? At federal level, how many percent of this profit is the company is donating? Is 40%.
10%. Okay, is it 40%?
Of F, right? While at the C, the charitable contribution is what? 10% of C. While at the state level, the S, we have this equal to, at the state level, we are contributing what? 5% of what? Of the state profit. Are we seeing it? Hello, class.
I thought it was the state that was 40%, not the federal.
The state is 40%.
Yes, check it.
It must pay a state tax of 5%, while the federal level is the one, the 40%. This is how it is.
Okay, it's all right.
So now we are going to develop our what? The system of linear equation. So now the system of linear equations are: number one, what is the value of what? Charitable distribution. We declare C to take equation 1, this to take equation 2, and F to take equation 3. Therefore, now the C donation will be what? The 10%. What is the what company is donating to the what charitable contribution? Is what 10% of it is what? Profit. Are you with me? Hello, class.
Go on, go on.
Are you seeing this? So the C output is equal to what? The C donation times the company profit, which is $100, minus, since we are taking C now, we have to subtract the outcomes of what? What remains if we take C pigs? Class. Hello.
We are with you.
I'm asking, I say what will be if we are computing what the charitable contribution of the company. We take what is the donation of charitable company is what 10% of it is profit. Are we seeing it? Are you with me? So since it is what we are computing what? The C part. If we are taking C part, we are going to subtract F and S. If we are taking S, the state level, we are going to subtract F and C. I've already demonstrated it here. Are we seeing it? Okay, let me continue since. So we subtract, we are computing the charitable contribution, so we land with what? S plus what? F. So now our C equals to what is 10% of this result? 10% is what? 10% is 10 over what? 100 times $100,000 minus the contribution of S plus what? F. So we manipulate this 10 divided by 100. Let's go with this. We have a 0.10 bracket open minus what? S plus what? F contribution. So we call this equation 1. Similarly, we now move and compute what? The state level. We compute for charitable contribution. We now proceed and compute for what? The state. We also compute what? The federal level. So now at the state level, but remember, if we are always the state is always the proper subset of what? The federal contribution, right? So at the state level, we assume that there is no what? The federal donation at the state level. So at the state level, we assume that F is what? 0. Since we are computing what? The result at the state level. So therefore S equal to, what is the contribution of S? The company is contributing 5% of this
5%.
of this profit. So in this case, we have 5% will now be 5% of what the company income minus the charitable contribution plus what the federal donation. But at the state level, the federal contribution is what? 0. So in this case, we have 5%, we got 5 over what? 100 bracket upon the company profit minus the C contribution plus F is what? 0. Are we seeing it? Hello? At the state level, the federal donation is set to be what? 0. So therefore, we make the substitution. We make the substitution now. 5 divided by 100 is what? 0.05. Bracket upon the total company income minus what? C. Because at the state level, the federal level is set to be what? 0. Are we seeing it? So therefore we manipulate this. So we can come back, we now move toward the federal contribution, which is equal to what? The 40% of federal donation, bracket on total company income, minus what? Minus
C
what?
C plus
Fixing F.
C
Yes?
C
Any
plus
question?
S.
Excellent. So we are taking F to the place. We now have C plus what? S. Then at the federal level, we need what? Both the state, both the local government, if it exists, and what even what? The charitable contribution. So at the state level, the federal level is set to be what? 0. Because we are computing the state category. But at the federal level, it is comprised what? Both the state, even if the local government donation is given. So in this case, we do the computation where 40% is 40 over 100, bracket over the total company profit earning. So bracket upon C plus what? S. So we now manipulate this. We have 40, 0 go ahead with 0. We divide this, we have 0.4. Then we always rearrange it in 1, 3 decimal, 3 significant table. So we have this equal to company income minus C plus what? S. So in this case, we have how many equations? Let me call this equation 3. This equation 1, and this one is equation 2. So we have to further what? Simplify this to make it to be what? Looks like a system of what? Linear equations. So we start with what? The charitable contribution. We manipulate this, we have what? C equal to, we expand the bracket. 0.10 manipulated, what do we have? 0.10 times 100,000, what do we have? Hello class. What do we have?
Did you say 0.1%?
Bracket here, look at this. 0.10 times 100,000, what do we have? We have 10,000, I think.
You have 10,000. 10,000.
So we have what? 10,000 minus minus an operator is acting over this, so we 0.1 times S.
That's S 0.1.
Always put the number first, followed by what?
Okay.
The variable. So we have 0.1 S.
0.1
S.
S.
0.1 S times C. What do we have? That minus, look at this, minus times S, you have minus S. Minus that always expand the inner part of the bracket.
Yes.
So we have minus S. 0.1 times
Minus
S.
0.1 C.
F.
F. Yes, F.
So try to make what the variables from the left hand side. So this will give us C plus what? 0.1 S plus 0.1 F, and this equals to a 10,000. This should be our
10,000.
equation what? 1, not Roman figure what? I. Are you with me? Are we there? Hello, house. Are you with me?
Yeah, we are with you.
So this is our what? Entire equation 1. So we now go to the step level. We expand this guy. We have S equal to,
You see?
0.05 times what? 100,000. What do we have? Look at this. Let me cycle this. We have this because we are going to use it to solve our model. Expand this guy. What do we have? 0.05. That is the 5% of what? The state donation times total income. What do we have? Expand it. Let's move. We are still in example 1. Eh? What do we have? 5,000, right? Okay, let me take the whole equation so that for better understanding. We realize that equation II is S equals to 0.05 bracket of the total income minus what? The charitable contribution. Because at the state level, the federal donation is 0, right? So let's expand this completely. We have 0 times this, we have 5,000 minus 0 times C, we have 0.05 C. So take the variables from the left hand side, we have S plus 0.05 C equals to what? 5,000. So we call this equation what?
5,000.
Are you with me? So we also proceed to the federal contribution and see. So we now proceed to the federal contribution. Look at the result. So we have F equal to 0.40 times 100 is what?
Malam,
Yes?
I suggest you should be using only the right hand side of the board. The left hand side is very blurred.
Then let me see if I can make it to be.
Okay.
What of now? Is it okay?
It's not. Just clean this right hand side and be using it. Or you don't want to clean it. You want to make reference to it again.
Okay.
Then
I
you
want
can
to
shift
make
the camera
reference to
to the
it,
left hand
but
side
since
if you don't want to do it. That is good.
okay, don't worry, let me use it.
We can move the camera down.
So now from the then let me resolve this one. So we proceed and expand this to find what is position for F. So this implies expand this guy, we have what? We take 0.4 before expansion. We treat the inner part of the bracket. We have minus c minus what s, right? I just expand this bracket. Minus times c minus c minus times plus is minus. With s we have this. So we now proceed to expand this guy. 0.40 times 100,000 we have what? 40,000 minus what? 0. This guy we have 0.4 c. 0.4 times that guy we have minus 0.4. Let's say even 0s. So take the what? The unknown variables to the what? To left hand side. So this will now give us equation 3, which is f plus 0.40c minus, plus 0.40 with s equal to what? 40,000. This is equation 3. So now our target is to what? To solve the system of linear equations. So what equation 1 say? Hello, house. What equation 1 said? Equation 1 said dc plus 0.1s plus 0.1f equals to what? 10,000. This equation 1. Second equation is what?
F.
0.5, 0.05. Is it F? Equation 2. At the state level, F is 0, right? So you have 0.15C.
F is 0.
Yeah, F is 0 plus 0. Let's say plus, we have S here. So what is our S here? Plus S plus 0 of F equal to 5,000. Equation what? 2. Then the last one we had, we just copy and paste it here. The first number we are writing is C. So take the C term, which is 0.40 of C, plus followed by the S middle term, 0.40 of S, plus the last term, which is F, equals what? 40,000. Equation 3. So we now solve the system. Any method that we know it will give us the answer, we can be able to what? Use it to find the solution. Any method we intend to them, we can be able to use. Someone choice may need to use what? Matrix method. Some will use, and even someone can use what? The software to do the computation. Any softwares to solve the system. Some they use simultaneous linear and the equations. Some will use substitution method, or any method that we know it will lead us to the answer we can use. So let's use a little bit of mathematical manipulation and see. So if we take a look at this one is already 0 of f, right? Are you seeing it? From equation 2, we don't have f. So let's try and eliminate f from equation 1. From equation 1 and 2. Right? Are you with me? So from equation 1 and 2, we try to eliminate a variable f by what? By multiplying 0.2 minus 0.1 times equation what? 3 minus 0.1 to equation 3. Are you with me? Hello, house. Are you with me?
We are with you. We are with you. Fire
so
up.
multiply equation 3 by minus 0.1. What do we have? Eh? So here we have equation 3 will now become this one times 0 point minus 0 point we have minus 0.4c. Multiply this one as 0.1, we have minus 0.4s. Multiply this by 0.1, we have minus 0.1f. Multiply this by 0.1. We have minus 4,000. So we manipulate this. Are you with me?
Yes, yes.
So now this equation what? 4. So add equation 1 and 4 to eliminate what? To eliminate f. So by adding this, guys, this equation 4, right? So we add it together. And we add it together, right? Equation 1. As you can see it by what? Equation 4. So you have 1c, c minus 0.4c. So the coefficient of c here is 1. We are adding. Look at what I'm doing. Let me even write it for clear understanding. We have plus 0.15 1s plus 0.1f equals to 10,000. We said it's equation 1. We also have equation 4, which is minus 0.4c minus 0.4s minus 0.1f, and this equals to minus 4,000. This is equation 4. So we want to add this. What do we have? The first one, 1 minus.
That's 1 minus 0.4 c. 1c minus 0.4 c
Is
will
what?
give us 0.6
c. 0.1 s 0.1s minus 0.4, we have minus 0.3 s. F go with f, and this equal to 10,000 minus 4,000 is what?
6,000.
We have 6,000. So this equation what? 5. We take equation 1, 2. So we compare this with equation 2, which is 0.5, 0.0, 0.0 c plus what? S equal to what? 5,000. We call this equation 1, 2 already. This is our equation 2. So we now want to use the simultaneous linear and the equation. This is simultaneous linear and the equation. So we want to solve S and what? C. So after we obtain the value of S and C, we can be able to substitute it back to what? To either equation 1 or equation 3 to obtain the remaining value of what? F. So let me delete this. So look at this equation what? 5 and 2. So what is the method that we are going to use easily to find the value of S and Are we going to use substitution method or elimination method? Which method do we want to use?
Hello, Malan, can you that last question, can you write it up so we can see it?
So let
Because
me
it's
realize
below the camera.
we want to solve
Yes.
0.6c minus 0.3 s equal to 6,000. Equation 5. We have also 0.05 s, sorry, 0.05 c plus s. We said this equal to 5,000. Are we seeing it now?
Yeah, we can see it now.
So we want to solve this simultaneously. Let's use elimination method or matrix method. Any method we use, we can be able to find. It's very simple to do. So to eliminate s, we multiply equation 2 by what? 0.3. Are we seeing it? To eliminate s here, we multiply by the coefficient, the first one. This one negative, this one positive, so they will cancel off. Are we seeing it? So let's proceed. Equation 1, multiplied by equation 1 by 1. We have 0.6c minus 0.3s. It equals 6,000. That's equation 5. So multiply this by 0.3. Multiply equation 2 by 0.3 and add up. Zero point 3 times 0.05. So this one will be 0.015c. Multiply this here plus 0.3s. And this equals to multiply this by 0.3. We have 1,500. This will now be equation 5. Let's say this to be equation 6. And this, okay, let this to be equation 5. We didn't change it. Let this to be equation what? 6. So add equation 5 and 6. What do we have? Zero point 0.6 plus 0.15 what do we have? This will now give us 0.
Is it 0.15 or 0.015?
0.015.
Yes, because you say 0.15. That's why.
No, add this one. We are adding equation 5 and 6. 0.6 plus 0.015. What do we have? 0.615 of C. This one will cancel. So we add this 7,500. This will now be equation 7. So we can divide both sides by a coefficient of C. We divide both sides by a coefficient of C. 1,5. This go ahead with this. Therefore, we have charitable contribution is now equal to 7,500 divided by 0.1, divided by 0.615. So this gives us what? 12,195 approximately. So this is the value for what? C. So from the question 2, we can be able to find the value of what? S. I hope this one is clear. So since we know the value of C, we can substitute back the value of C into equation 2. So from equation 2, we have S equal to 5,000 minus 0.05 of C. But C equals to what? 12,195. So this implies S equal to 5,000 minus 0.05 bracket upon the value of C, and it equals 5,000 minus, we expand the bracket first, 12,195 times 0.05, which will give us 609.75 with no approximation. So we subtract this 5,000 minus 609.75 with no approximation. We have S equal to 4,390.25 with no approximation. So if we take the approximation, we have the value of S equal to this. So now we can use equation 1 to find the value of what? F. So we see that now we have that our S, what we are contributing to the state is 4,390. The charitable contribution is 12,195. Then what is F? The federal level. So from equation 1, we conflict the value of F as follows. By substituting back the value of what? F, by substituting the value of what? C and S into the value of what? F. But remember that F equal to, but remember that F equal to 0.4%, that is 40% of what the total company income minus what? The state plus the charitable what? Income. So this equal to 0.4 bracket of 100,000 minus what is the state? The state is 4,390 plus the charitable contribution 12,195. So we manipulate this to give us what? The answer. So let's take inner part of the bracket. 0 behind a small point is nothing. So then we have this minus, let's add this C and S. Add C and S, what do you have? 4,390 plus 12,195. We have 16,585. So we proceed. We have 0.40. We have 100,000 minus this guy. But this bracket is, so we just subtract this 100,000 minus 16,585. We have this equal to 83. 83,400 and this. So we just multiply this, we multiply, so our F. So at the federal share is now going to be what? 0.4 times 83,415. This will give us 33,366. So these are the contribution that the company give to the federal level charitable contribution and the state. So Kamal, please share let's go back to the document. Hello, Kamal. Is Kamal around?
No, he's not online.
So let me share the.
Chisom, I'm with you. I'm with you.
Okay, can I ever share the?
I'm not on my computer. It will take some time before I get to my computer.
No, I'm talking to Kamal.
Okay, Kamal is not online.
Okay, so let me share my own. Okay, it's there. So as you can see, this is the outcomes of the result. So even if not that we encounter some few approximations, whether it's random error or approximation error, or even truncation error, please try to tackle the case. So let's go to the next slide. Let's move to the next slide. So this is the detailed analysis. Next, we have done this already. Go to the next. This is the mathematical model, and this is what we have solved. Go to the next. So this is model of the production, which is very similar and relevant to the one that we have done. So this is the production model. As you can see, the linear model of production are perhaps the simplest production model to describe. Here we will describe the simplest of the linear model, where we encounter only two unknown variable. That is the number of goods that we are producing at so time, and the number of the goods that we are selling at particular period of time. So this production model is the most simplest production model, because it describes only what the number of goods that being produced, and the number of outcomes of the product that we being generated as also particular company. Let's proceed. We see an example. So as you can see here, we give a brief example of the production model that describes a company, and what is the money that he spent. He buys also bags of the fertilizer. At the end, what is the profit? So we indicate X of F to indicate number of fertilizer and the number of cons. What is the number of fertilizer or ingredient you use to cultivate a piece of land? So the number of money that you spend should always be less than the number of profit that you earn. So let's go to the next slide. So this is the continuation of the model. As you can see, we have this. We give a counter example. The amount of the corn left over the consumer will be total amount they produce. So since this equal, so you write X of C to the number of corns and X of F to the number of fertilizer that are used in cultivating a social piece of land. So we are assuming that both x of c and f of x of f has a so coefficient where we indicate the coefficient of fertilizer to be equal to 0.5 and the coefficient of corn that we produce to be 0.1. So we have two systems of linear equation, as you can see, equation I and equation what II. So this system is very simple to handle. Just do a substitution method or what do we call it? Substitution method or elimination method to find it. It's very simple because the system is of two equations. So a system of n-term equations is very difficult to solve. But this one is very simple. Make x of the subject, substitute back to equation 1, you obtain the result. So let's proceed. So as you can see, the system is easily solved. So the second equation terms we make x of f the subject, substitute back to the second equation. Substitution, you make all the equation to be what? Equation of the c term. So solve for c, then substitute back for the position of x of f. And this will yield the result. Let's go to the next slide. Let's move to the next. So this is our target. Once we have a population model, how are we going to do the generalization? So assuming that a company is producing different amount of goods, maybe the company is producing sugar, is also producing beans, producing rice at the same time. So in this case, we are going to have what n commodity as also period of time. So this is our target. How can we generalize the population model or the production model? So in this case, we assume that a single company has capacity of producing n amount of goods. So allow me to share the board so that I can let me use the board for detailed explanation of this generalization. 1 minute, let me present the result on the board. Let's do the generalization and see. So the example that we have just finished solving, it only comprises of what? Three distribution category: the state level, the charitable contribution, and the federal level. So assuming that a company producing n amount of goods, assuming that a company is producing, are you seeing my writing? Are you seeing the board? So if a company is producing n amount of goods, so in this case we assume that, let's assume that the first one is producing the what? The corn. The one is producing what? Fertilizer. The one is producing rice and so on. So assuming it means that each of this amount has n different columns. So x of c is producing x1. What is the instrument used in producing x1? We call it maybe a1 x1 plus the second amount of good a2 x2 plus the third amount of good a3 an x3 plus dotted line up to plus 1 an xn, and this equals to c. So if the company is producing n amount of what? Goods, then it's going to have a generalization of this form. Assuming that S of F is producing, let's say B.
Hello, Mala.
Yes?
I don't know if it's me, but I can't see your board that you are working. Are you working on the board already?
Yeah, I'm just start showing the what generalization of the what of what we have just done. Let me see if I can. Is it okay like this?
The generalization slide that you were sharing before.
Yeah.
I can't see this on the board. You are working on the board already.
I want to show you what a clue on the generalization that I just shared.
No,
But are
stop
you working
sharing
on
your screen
are you
so that
working
we
on the
can
board
see.
or you're on this?
Okay.
It's like Kamal is still sharing screen.
So let me continue with the slide. Don't worry. Okay.
The screen is done.
So you can see
Yeah,
it like this.
wow.
So
You can
we
see
said
it.
that assuming that, let me come back again. What we said, we want to generalize the system. The one that we just finished solving for the production model and what the linear mod, the system of linear equation, we solve for charitable contribution. All those ones are up to what, 2 variable and 3 variable. The one that we solve with the federal level, state level, and what the charitable contribution. The second one is describe only x of t and x of what f. This one is what the number of corn that we produce at so company, and this is the amount of fertilizer that we use. So this one is very simple one model to solve because it is of 2 variable and of 3 variable. So assuming that a company is producing n amount of goods. So this one you can use what elimination method or substitution method to handle this. Rather than we either use what the n term polynomial for proving this. So in this case, assuming that we have the system of linear equation like this, a11 x1 plus a12 x2 plus a13 x3 plus dotted line plus a1n xn we set equals to c1. We also have a21 x1 plus a22 x2 plus a23 x3 plus dotted line plus a2n xn, and this equal to c2. We also have a31x1 plus a32x2 plus a33x3 plus dotted line plus a3n xn equals to what c3. So if we have this kind of system of linear equation, as you can see, we have what cm, or let me even say cm. We have an1 x1 plus an2 x2 plus an3 x3 plus dotted line plus an n xn equals to what? Cn. So assuming that we have a simple model that has this global generalization, are we going to use what? The substitution method or elimination method like what we have done in example 1 to find the solution of this task?
It will be hard to use that.
It is very difficult to do this. So in this
Yes.
system, we need to deploy another method of the computation of this. So in this case, we have to endorse this into what? A matrix representation. So in general, the system here has a summation of the I equals to 1 to n of what xi with j s of I. So this summation, it requires a representation of what A will be the coefficient I and j. Then the summation will now act on what xi. So this one has a matrix representation. AI is the matrix coefficient, right? So this we have A11, A12, up to A1n. Are you with me?
With you, fire on.
Okay, so we have A21, A22, and so on up to A2n. So in this case, we have this what we call the matrix N1, N2, up to what ANN. In this case, this one, since it is X index, we have X1, X2, X3, up to what Xn. So this is another what a representation. So in analyzation of what a production model, we need to endorse a techniques and the skills that will require a matrix notation for solving the solution. So this representation, we can be able to find the eigenvalue and eigenvectors that will generalize the whole result. I hope it's clear. So therefore, we need the tactics of what matrix representation in order to find the general solution for generalization of what production model. So in this case, we are not given only what the state level, the contribution level, and the other one. Rather than we are required to what to give a global generalization. And this method so in this case, we need to give what a generalization of the problem. And this can be tackled by what the notion of matrix. So by now, the students are required to go and revise what details of matrices. How can we represent a what a linear system into a matrix representation? How can we compute what eigenvalue, eigenvectors? How can we transpose a matrix? How can we what invert the matrix? That is to make a matrix to be invertible. For a matrix to be an invertible, it requires to be what? To be a non-singular matrix. If the matrix is non-singular, if the matrix is singular, we have nothing to prove. So for some generalization of this model, we need to have a skills of matrix representation. So therefore, we need to endorse the solution of this generalization is either we use what? Rho reduce echelon form, number one. Number two, or we endorse, we use reduce echelon form, or we use what? Gauss elimination method. Any of these will lead us to find the solution of the generalization of the system. Recall that in any one of these, our target is to make the subsequent result here to be equal to what? 0. So let me see if we can be able to give a representation of Gauss matrix for the generalization. So in this case, we have a matrix like this. We have the coefficient x1, x2, x3, up to what xn. We have the result equal to c1, c2, c3, up to what cn. So in this case, the coefficient, our target is from equation 1, we have the whole result, a11, a12, a13, dotted line up to what A1N. So the second part, our target is to make this one to be what? 0. The first term to be what? 0. Are you with me? Hello, house. Are you with me?
Yeah, we
Okay.
are with you. We are with you.
So our target is to make what the first equation we leave it the way it is. The second one, our target is to make the first variable of the second equation to be what? 0, followed by a what? What will be the next variable? What will be the next variable? And the next thing, this one is A11. We now eliminate what? A21. So we left with what? A22, A23, dotted line up to A2N. The next one will, first one, this one is 0, so the second one will be 0. The third one will be 0. Second one will be 0. The first one is okay. The second one, first variable will be eliminated. The third one, two variables will be what? Eliminated. So we left with what? A2, A3. This A31 is 0, A32 is 0, A33 is there.
833.
Yeah, so we left with what? A31N. So we continue in this fashion. This one is 0, this one is 0, the third one is 0, dotted line up to what? The last term. So in this last term, we require to have A. Let me do it like we require to have A, the last term. Only last term we require to be existed here. So what will be the last term? A. The last term will be A and N, because as we proceed, this one is also what? Increasing, as N is what? Increasing. So our target is to leave what? Where the position i's are what? Equal. Do you see it? Are we seeing it? A11 exists, A22 exists, A33 exists, A44 exists, A55 exists, ANN exists. So all the coefficients, provided that A of I and J, such that I equals to what? J, then anything of what exists, then anything below is what does not exist. A11 exists, but A21 does not exist. Our target is to start from the fresh A22. The third one from A33. The fourth equation from A44. The fifth equation from A55. All the rest will exist, while the below ones are what? So what our target is to form what? A triangular form. So in matrix representation, either Gauss-Jordan elimination or Gauss elimination method, our target to write the given matrix coefficient in upper triangular representation. I hope it's clear. Hello, house. So let's come up, please. Let's go back to the slide and continue. Let's move to the next slide. So you can see the generalization. As you can see, we are trying to eliminate what the variables below. Let's proceed. Let's move to the next. So the generalization which we have shown it on the board up towards Cn. So the linear system. No, go to the next slide. The conclusion. We have done this one already. So linear system is called an often long-lived system after wisely long-lived. This is the what an economics that define this. Who first studied the type of system in what in 1930s and later won a Nobel Prize in economics for his work. He is the one that was showing generalization of n terms commodity representation in linear systems. So let's proceed. So model of unemployment. The model of unemployment basically represent the what, how these two or the condition of getting a job. So if we have some individual is target. So in model unemployment, we basically used to consider what the two cases: the number of suspects and the number of what not successful in seeking the job. As you can see it here, we said the aggregate unemployment rate do not tell us the whole story of unemployment. In order to that appropriate income, so we need to determine the number of the success and the number of what failure. So let's go to the next slide. The explanation idea well explained. Let's move to the next slide. So let's denote the probability of getting a job in a given week as PW, while the number of people not getting job at a particular week we denote it with Q of W. Similarly, we'll denote the probability of getting the job for a particular month with P of M, and not getting job with a particular job will be what? Q of M. Please. Okay. So we declare P of W to indicate what number of success that get a particular work in a week. While Q of W, the number of the students that didn't, or the job seekers that didn't get the work within a particular period of time in a week. So with also the month we declared as this. So in this case, if the number of success is P, the number of failure is Q, then the number of success is equals to what? The total number of success plus number of failure is equals to what? 1. So the number of success will not be equals to 1 minus what? Number of not getting job at so particular week. The same thing with a month. So a simple demonstration, as you can see it here, is very simple. For a week, we have equation 1. For a month, we also have equation 2, as you can see it. So the solution of the number of jobs that get a particular work basically on the month is dependent on the number of success for a weekly. So the same thing for yearly probability are also meant the same. So let's proceed to the next slide. So as you can see here, we give the counter example. We make a substitution by assuming Q of W and Q of M have a what? A similar result. So if you look at this, the number of people that get job weekly is equal to the number of people that seek a job monthly. So if we take the difference for the not getting job weekly with that they didn't get a job monthly, if we take the sum, the result is equal to what? 0.7 plus 0.3, and this will be equal to 1. So in general, whenever the probability of any given event is greater than 1, then such the outcome is not a what? More a probability. So for it to be probability, it has to, if we take the sum of the success plus the sum of the failure, the outcomes will be equal to what? 1. So probability is always bounded from 0 to what? 1. So number of success is 1, number of failure is 1. And the outcomes can lie between 0 and 1. So let's proceed to the next page. Let's proceed to the next page. As you can see, investment and arbitrage model. This is another more investment and arbitrage model are two important concepts in finance and economics, and they can be modeled using the linear equation. So let's discuss each of them. Number one, as you can see on the board, we illustrate the word investment model. Investment model refers to the word allocation of resources such as money, time, or effort, with the exception of generating what? Future income or profit. So impedance investment can be what? Model using the linear equation to analyze the relationship that exists between investment return and other relevant factors. Such factors are what? Such factors include the time of getting what? Income, the net revenue, and other associated factors that are related to the what? The given model. So the nature of the model is depending on what the variable or the resources which are allocated to the given problem. So let's move to the next slide. So this is the general typical representation of the model. One common investment model is the capital asset pricing model. We call it what? CAMP. So this CAMP has a lot of what? Representation. So we need the simplest representation where the students are required to go and look at somewhat more examples of investment models. So they are linear and they are simple to what? Compute. This is the arbitrage, which is very related to what? To the investment model. So let's move to the next slide. So we also have this the generalization where ER of T is what expected return on the set. Alpha of I is the expected return not explained by the factor, while beta of I and J, where I and J are indexed, so are the sensitivity of the word asset. Sometimes we call them what? A carrying capacity of the relationship. So let's move to the next slide. Let's move to the next slide. So now the APT model allows the analyst to identify the mispricing in assets based on their sensitivities to microeconomic factors and what potentially profit from the arbitrage opportunity. So in summary, investment arbitrage can be analyzed using the linear model such as CAMP and FET, which provide the valuable insight into expected returns, risk factors, and profit opportunity in financial market. So this model helps investors and analyze, make informed decisions about the resource allocation and risk management. So what we should do in the next class, we will find a numerical computation of each of these investment model and what? The arbitrage model, and trying to find their what? Unique representation of their what? Solution. So that is the end of the today's class. Any comment, any question, any observation? Thank you all. So if you come during the tutorial class, we will pick some numerical example of each model and do the solution. More especially like the production model. So we take a probabilistic problems and we try to find the solution. And a sequence of exercise is going to distribute on Friday. Thank you once again. See you next time. Bye.